Today we are going to discuss a very important rule to evaluate indeterminate forms. So let us talk about indeterminate forms first. So the forms given below are called indeterminate forms. 0 upon 0, infinity upon infinity, 0 upon infinity, infinity upon 0, 0 into infinity, infinity minus infinity, 0 raised to the power 0, infinity raised to the power 0, and 1 raised to the power infinity. Since these expressions are considered to be senseless in mathematics, so they are given a particular name, that is indeterminate forms. So this rule is about a limit whose direct application gives us any one of these indeterminate forms. So now let us talk about L'Hospital rule. So according to L'Hospital rule, if Fa upon Ga is equal to 0 upon 0 or infinity upon infinity or 0 upon infinity or infinity upon 0, then according to L'Hospital rule, limit x tends to a fx upon gx is equal to limit x tends to a f dash x upon g dash x. That is, if direct application of limit gives us fa upon ga, which is equal to any one of these four indeterminate forms, so we differentiate numerator and denominator separately, and this limit has the same value as this one. And again, if f dash a upon g dash a is equal to 0 upon 0 or any other these four indeterminate forms, the original limit, that is limit x tends to a fx gx, is equal to limit x tends to a f double dash x upon g double dash x, and so on. We go on repeating the same process until we have a finite or infinite value of the limit, but not indeterminate forms. Now let us take an example to understand the application of L'Hospital rule. So here it is. Suppose we have to evaluate a limit x tends to 1, x raised to the power 5 minus 2x cubed minus 4x squared plus 9x minus 4 upon x raised to the power 4 minus 2x cubed plus 2x minus 1. So if we apply the limit x tends to 1 to this expression, let us check what happens. If we substitute x is equal to 1 in this expression in the numerator, so we have 1 minus 2 minus 4 plus 9 minus 4. That means two positive numbers 1 and 9, that is 10, and 3 negatives minus 2 minus 4 minus 8, that is minus 10. So plus 10 and minus 10, that is 0. And in denominator we have x to the power 4 minus 2x cubed plus 2x minus 1. If we substitute x is equal to 1 here, we have 1 minus 2 plus 2 minus 1. So plus 1 minus 1 cancelled, minus 2 plus 2 cancelled, and we have 0. So ultimately we have the indeterminate form 0 upon 0 by direct application of the limit. So according to L'Hospital rule, limit x tends to 1, the differential of numerator is 5x to the power 4 minus 6x square minus 8x plus 9 upon differential of x raised to power 4 is 4x cube minus 2x cube, differential is 6x square. Next term is 2x, differential is 2. Now let us check. Apply the limit x is equal to 1. We have 5 minus 6 minus 8 plus 9. So two positive numbers, that is 5 and plus 9, that is plus 14, and two negative numbers, that is minus 6 and minus 8, that is minus 14. So plus 14 minus 14 is equal to 0. So in the numerator we have 0. In denominator we have 4 minus 6 plus 2. So we have two positive numbers, that is 4 and 2. So sum is 6, and one negative number, that is minus 6. So minus 6 plus 6 becomes 0, and we have 0 in the denominator, and ultimately we have indeterminate form 0 upon 0 by direct application here in this step. So according to L'Hospital rule, once again we have to differentiate numerator and denominator. So first term is 5x to the power 4, and the next differential is 20x cube, and next term is minus 6x square. The differential is minus 12x, and the next term is minus 8x. Differential is minus 8, and because 9 is a constant term, its differential is 0. In denominator, the differential of 4x cube, the differential is 12x square, and minus 6x square, the differential is 12x. So let us check by substituting x is equal to 1 in numerator. We have 20 minus 12 minus 8. That means one positive number, that is 20, and two negatives. Minus 12 minus 8, that is minus 20, plus 20 minus 20, 0. And in denominator, we have 12 into 1, that is 12 minus 12, which is equal to 0. So again, we have 0 upon 0 indeterminate form. So according to L'Hospital rule, we have to carry on this process. So we have to differentiate once again the numerator. So the first term is 20x cube, and its differential is 60x square, and minus 12x, whose differential is 12. So in numerator we have 60x square minus 12, and in denominator, if we differentiate to 12x square, the differential is 24x, and the next term is 12x, whose differential is minus 12. Now let us check. If we substitute x is equal to 1, now we have 60 minus 12, which is not equal to 0, so we can apply the limit in this term. So 60 minus 12, and in denominator 12 minus 24 minus 12. So we have 60 minus 12 upon 24 minus 12, and ultimately, which is equal to 48 upon 12. So 12 fours are 48, and 4 is the ultimate or the final result of this limit. So this is how we use L'Hospital rule to evaluate a limit